So I hope that you knew not to cancel the 5z to the fourths yet at this point. The 5z to the fourth down here is a term, not a factor, so it cannot be canceled. What I'm going to have to do is factor. Now the numerator is already factored, but in the denominator there's a GCF of 5z to the fourth that I can take out. That'll leave 2z minus 1. Now the 5z to the fourth that I see in the denominator is a factor, right? It's multiplying the rest of the stuff in the denominator. That's what a factor of the denominator is. So we'll cancel those, remembering when you cross things out, what you're getting is sort of invisible factors of 1. So I'm left with 1 over 2z minus 1. Then the second one had factoring that was a little more challenging, but hopefully it went okay for you. These actually are, I think, probably substantially tougher factoring problems than I actually did in the example, but that's okay. You've reviewed this lately. Now, these both look hard enough to me that I might not use trial and error. Well, this one on top, I think I just spotted the factorization. So I'd have a 5x and an x, and I need either a 6 and a 1 or a 2 and a 3, but it occurs to me that if I put a 2 there and a 3 there, I'll have 5x's plus 10x's plus 3x's, which is 13. So that one actually I just kind of stumbled upon. For this next one, the factorization isn't jumping out at me, so I'm going to go off onto scratch paper and do use the AC method. So remember with the AC method, and again I'm going off on scratch paper here, so you might want to put this off to the side or something. Anyway, remember with the AC method, you look for two numbers whose product is AC. So 6 times negative 10, so negative 60. And those two numbers have to have a sum of B, the coefficient on the X. So the sum has to be 7. So I'm looking for two numbers whose product is negative 60 and whose sum is 7. Let's see. Would negative 6 and 10 work? No, that's not going to work. What about 2 and 30? No, that's not going to work. How about 5 and 12? That'll work. Now, what negative 5 and positive 12? Now, what you do with those two numbers, unfortunately, they don't just get thrown into parentheses, and that's why I went off to scratch paper to do this. What you do with those two numbers is you use them to split up the middle term. So I'm going to rewrite 7x as negative 5x plus 12x. And then you use the grouping, on that. So I'll take an x out of the first two terms. That'll leave me 6x minus 5. I can take a 2 out of the second two terms. And then what happens is you get the same thing in both sets of parentheses, so you can factor it out. So 6x minus 5 and x plus 2. Okay, so that's our factorization up here. And if you were able to do that by trial and error, well, good for you. Okay, so 6x minus 5, x plus 2. The x plus 2's are common factors, so I can cross them out. And my final answer then is 5x plus 3 over 6x minus 5. Okay, so congratulations if you got through that okay. Next, I want to look at a cancellation that, some cancellations that look deceptively simple, but are a little bit subtle and can be confusing. So first of all, suppose I needed to simplify the fraction or rational expression 5 plus x over x plus 5. Hopefully you can see that will cancel as a 1, right? Because using the commutative property, we're using the commutative property when we do that, because 5 plus x is the same thing as x plus 5, right? So 5 plus x, so 5 plus x over x plus 5 is the same thing as x plus 5 over x plus 5, which is a 1. Okay, and you don't have to write all this. I just want to make sure you understand it. Now, what if we had 5 minus x over x minus 5? Be careful here, because 5 minus x is not equal to x minus 5. In fact, 5 minus x and x minus 5 are opposites, right? So if I'm working on simplifying this fraction, I need to understand that 5 minus x over x minus 5 is not going to be a 1, but 5 minus x is the opposite of x minus 5. And I'm going to put in some steps, hopefully, to make sure you understand how it is that x minus 5 and 5 minus x are opposites. But let's say I factor a negative 1 out on top, and I'll have negative 5 plus x in parentheses. Agreed? Okay. And hopefully we'll also agree that negative 5 plus x is the same thing as plus x minus 5. Maybe actually go ahead and keep that 1 there. Now I have common factors that I can cancel, right? I could think of this as x minus 5 times 1. So I'd have negative 1 over 1, which is negative 1. So when you, if you go to simplify binomials where the terms are in the opposite order, if they have plus signs between them, you get, when you cancel, you get a positive 1. If they have minus signs between them, when you cancel, you get a negative 1. And if you understand that, it's fine with me for you to just cancel and, cancel as a negative 1. If you find it helpful to go through the procedure I just went through, where you factor out a negative 1 so that you can see explicitly you have common factors to cancel, that's okay too. It doesn't take that much longer. So as always, do what works for you. Now, I just want to mention that, what I did here is I factored a negative 1 out of the numerator. If you find yourself doing this, don't worry about trying to remember, which one am I supposed to factor? Because we could have factored the negative 1 out in the denominator, and that would have been just fine. What we would have done in that case, so I factor a negative 1 out. If I do it in the denominator, I have negative x plus 5. And negative x plus 5 is the same thing as plus 5 minus x. So I cancel the 5 minus x's. I get 1 over negative 1, which is negative 1. So you still get the same thing. Just don't, maybe I should add a note here. Just don't factor out a negative 1 in both numerator and denominator, because you won't get common factors then. You'll have the same issue. So if I factored it out in both numerator and denominator, up top I'd have minus x minus 5, and down below I'd have minus 5 minus x. So I still wouldn't see common factors.